Now, from here we have the pendulum system. That is the next one that we are referring, the pendulum system. So here I have a pendulum where you can see that this thing here, we call it as a bob. Okay, and this is the rod. So when the mass or the bob is being released, it will start to oscillate or swing from its position to the mean position, and then towards the other side, that is the left, and then it will oscillate back or move back to its mean position and then towards the right. So this is considered as an oscillatory motion. For this is a pendulum. So on the mass or on the bob at position A, you can see, as you can see, there are three forces acting there. One is the inertial force of MA, the other one is the wave of the bob, and then the tension on the rod. So these are the three forces that is acting on the mass or the bob. So when it releases, it starts to swing or oscillates about its mean position. So on the pendulum system, okay, forces that is acting on at A, okay, so you have first is the wave, which is always acting vertically downwards. Two, you have the tension in the cord, that is F, stated here as F, or you can put it as T. And then the third one is the inertial force, M times A, where M is the mass of the bob and A is the acceleration due to gravity, or the acceleration of the mass. Sorry, it's the acceleration of the mass. Okay, so here you can see clearly that at position A, the bob or the rod is actually displaced by an angle theta, and L written here is the length of the rod, so it will move about or oscillate about its mean position. So based on the triangle, the right angle triangle that I've drawn from OAB, okay, the three forces at A, which is acting at A. So from the right angle triangle, you can see sine theta, that means the angle theta, that is the angular displacement of the rod. Okay, sine theta is actually equals to AB, that is the opposite, over OA, that is the hypotenuse. So, and we know that based on the forces that is acting at A, position A, or at the point A, you can also say that sine theta is equals to the inertial force, okay, that is AB, divided by mg, that is the wave of the bob, based on the right angle triangle, the triangle of force, based on the triangle of force now. Okay, it's not based on the length. And we know that sine theta will be equals to A over G as the mass, if it is being cancelled off, so you have A over G. And if sine angle theta is, the angle theta is negligible, that means very small angle, so sine theta actually can be written as equivalent to the angle theta only. So if angle theta is very small, so sine theta you can take as equivalent to angle theta only. So it's equals to A over G. Remember, A is the acceleration of the bob, G is the acceleration due to the gravity. So based on the arc length of AB, and since angle theta is small, then you can say S is equals to L theta. Okay, the arc length S will be equals to the length of the rod. You know that, okay, we know that the arc length is actually directly proportional to angle theta when any object is moving in a circular path. When any object is moving in a circular path from, let's say, this position here to this position, you have this as r, but in this case we have length L. So when it is displaced by an angle theta, so we can say that the arc length S is actually directly proportional to the angle theta. So in this case, what we have is the length. So L theta. So the length, the radius here is actually replaced by the length L here when the bob is moving in a circular arc. That means moving in a circular path. So you have S is equals to L theta. So based on this, we can get theta is equals to S over L. S is the arc length, L is the length of the rod. So based on both of these equations, when you equate both of these equations, okay, you will have A over G is equals to S over L. Okay? Or when you rearrange it, you have A over S equals to G over L. Initially, okay, we know that the circular frequency, which is equals to 2 pi over T, correct? Okay, and also we know that, okay, omega can also be equals to it's 1 over the frequency is equals to 1 over 2 pi square root of displacement over acceleration over displacement, right? So from this we have the circular frequency is equals to the square root of A over X. So you have, since A over X is equals to G over L, so it can be actually expressed in terms of the omega, or the circular frequency can be expressed in terms of the square root of G over L from this and this. Okay, so from here you have the period, the time period, because we know that from here omega is equals to 2 pi over T over the period or the periodic time. So the periodic time will be equals to 2 pi over, or 2 pi multiplied by 1 over omega. So that is why you have period S equals to this. So if you want to find in terms of the periodic time, so or you can write that frequency will be equals to 1 over 2 pi to the square root of G over L. Okay, so that's all for pendulum. So we have these examples or exercises here, which you can try to solve it before I publish the solution in your YouTube. Okay, thank you.